Assalamu alaikum. I am Abdullah Al Nasir Choudhury. Today I will give the presentation of CSC 305 and my ID is 2018331501. It's a privilege for me to share the topics, the combinational and sequential logic circuits. And I have made my presentation about these topics. So at the very beginning, uh, uh, as you can see, I have uh, let's uh, f- start from the definition of combinational logic circuits. So what is a combinational logic circuit? A combinational logic circuits are defined as the time independent circuits which do which do not depend upon previous inputs to generate any outputs are termed as combinational circuits. I have included some of the examples as adders, subtractors, multipliers, comparators, multiplexer and demultiplexer. So combinational logic circuit doesn't depend on the previous input. It only depends on the present state. So I have also included some of the characteristics of combinational circuits, and here I have included the outputs. The outputs are a function of the present set of inputs only. The inside of combinational circuit is made of logic gates. Combinational Combinational logic circuits are important component of digital system, and each output can be thought of as a function of all the inputs. If there are m outputs and n inputs, then there are m boolean functions, one describing each output. And I have also added another model or another figure about combinational circuits. It doesn't depend on the memory and no need to store the previous value inside the memory, as as we know that in the sequential logic circuit we store the previous input value inside the main memory. Again, in the next slide, there are some characteristics I have mentioned earlier. There's the output of the combinational circuit at any instant of time depends only on the levels present at input terminals. And secondly, the combinational circuit do not use any memory. The previous state of input doesn't have any effect on the present state of circuit. A combinational circuit can have a n number of inputs and m number of outputs. They have no memory elements. So these are the characteristics of combinational logic circuits. In the next slide, I have a, I will discuss about adder, which is an example of combinational logic circuit. So what is an adder? An adder is a digital circuit that performs addition of numbers. In many computers and other kinds of processors, adders are used in the arithmetic logic unit or ALU. They are also used in other parts of the processor where they are used to calculate addresses, table, indices, increment and decrement operations and similar operations. And there are two kind of header also. One is half header. What is a half header? A half header is combinational logic circuit which adds two 1-bit digits. The half header produces a sum of two inputs. What is a full header? Full header is the header which adds three inputs and produces two outputs. So on the right side we have a logic diagram of half header, and you can see there are, if I shift my camera, it will be much more visible. So there are two example of logic diagram of half adder. One is the truth table on the right side, and the left side I have included a circuit. And again the logic diagram of full adder and the truth table also I have mentioned. In the next slide, the example is I have chosen the example for combinational logic circuit, which is subtractor. So an electronic logic circuit of for calculating the difference between two binary numbers. The minuend and the number to be subtracted, the subtrahend, a full subtractor performs this calculation with three inputs: minuend bit, subtrahend bit, and borrow bit. So this is another example of combinational logic circuit. So as adder, there are also two parts. Number one is the half subtractor, and number two is the full subtractor. So what is a half subtractor? Okay, the half subtractor is a combinational circuit which is used to perform subtraction of two bits. What is a full subtractor? A full subtractor is a combinational circuit which is used to perform subtraction of three input bits: the minuend, the subtrahend, and the borrow bit. So the logic diagram of half subtractor I have also added there. On the right side you can see the truth table diagram, and on the left hand side we have added a circuit, and the logic diagram of full adder I have also added there. So these are the my second slide about combinational logic circuit. On the next slide I have added, now I will discuss about sequential circuits. So what is a sequential circuits? Sequential circuits are those which are dependent on clock cycles and depends on present as well as past inputs to generate any output. For example, we use sequential logic circuit in flip-flops and counters. So this is the figure that I have included. You can see there are clearly a difference shows there. We have a memory element inside our sequential logic circuit, but in the combinational logic circuit there are no memory element needed. So external inputs, the input goes and it show outputs, and of course the carry bit or the next state will come to the memory element and it will be added in with the external inputs. And these are the characteristics of sequential circuits. Unlike combinational logic circuit that I have mentioned there, you can see the output of sequential logic circuits not only depends on current inputs but also on the past sequence of inputs. And the sequential circuits are constructed using combinational logic and a number of memory elements with some or all of the memory outputs fed back into the combinational logic, forming a feedback path or loop. A very simple sequential circuit with no inputs created using inverse to form a feedback loop. So I have added a circuit diagram there. On the next slide, the sequential logic circuits are able to take into account their previous input state sorry state as well as those actually present. A sort of before and after effect is involved with sequential circuits. So input, these are the output, and also a positive feedback. It will store inside the memory, and they are also available clock signal, and the previous state will come and added will be the present input. So sequential logic circuit use flip-flops as memory elements, and in which their output is dependent on input state. And I have added some brief or some the description about sequential means. The word sequential means that things happens in sequence, one after another, and in sequential logic circuit the actual clock signal determines when things will happen next. Some sequential logic circuits can be constructed from standard vestibule circuits such as flip-flops, latches, counters, and which themselves can be made by simply connecting together universal. We know there are two universal NAND gates and or NOR gates in a particular combination way to produce the required sequential circuits. So in the next slide, if we go, so I have included some of the difference between combinational and sequential logic circuit. So what is a combinational circuit difference? It in this output depends only upon present input. So in combinational circuit it depends only upon present input, but in sequential circuit in this output depends upon present as well as past input. So these are the main difference. So in combinational circuit speed is faster and speed is slow. Why speed is slow? Because it depends on depends on not only the previous output but also it will have to add the present input. So it is much more obvious that the sequential circuit speed will be slow. It is designed easy, it is designed tough as compared to combinational circuit, because we have to add some of the flip-flop to collect the previous output, or the borrow elements inside our memory blocks. And combinational circuit is time independent, and the sequential circuit is time dependent. Elementary building blocks logic gates for combinational circuits. Elementary building blocks is flip-flops. And combinational circuit is used for arithmetic as well as boolean operations, and sequential circuit is basically used for storing the data, because we have already shown that there are a memory element part where we store our data. Combinational circuits don't have capability to store any state. Sequential circuits have enough capability to store any state or to retain earlier state. As combination circuits don't have clock, they don't require triggering, and as sequential circuits are clock dependent, they need triggering. These circuits do not have any memory element. Yes, we know that, but sequential circuits have memory element. It is easy to use and handle, but on the other cases, it is not easy to use and handling. And the next time, so that's all for now, and thank you for watching. And that was my presentation. I'm Abdullah Nasir Choudhury. Once again, I am introducing myself, and my ID is 2018331501. Thank you for watching. Assalamu alaikum.